Today, let's talk about Ubiquiti's very special access point, U6-Mesh. So this is everything inside the box. You have the small access point itself and some mounting accessories, the pole mount, wall mount, and the desktop mount. Unfortunately, it doesn't come with ceiling mount. You need to purchase separate part from Ubiquiti. And there's a surprise. The package comes with the PoE injector. For most normal Ubiquiti access points, they don't provide the injector. I believe because of the uniqueness of this access point, many people will purchase it for outdoor uses. A injector is more useful in those scenarios. I have to compare these Ubiquiti access points side by side because they are so similar from specification perspective. So the left side, the U6-Mesh, and the right side, U6 Pro, they have almost the same hardware specification, but from the looks, they are so different. And the U6-Mesh, because it's so small, because the enclosure is aluminum, it even feels heavier, even though it's in fact a little bit lighter. Let's look into their specifications on paper. These are the data sheets from Ubiquiti. You can see they have the exact same MIMO ability, exact same throughput. For antenna gain, U6 Pro is a little bit higher. That's why it needs a little bit higher power consumption. But basically, they are almost the same from access point perspective. But if you check the weatherproofing part, the U6-Mesh, the last digit is 5. U6 Pro is 4. This difference means the U6-Mesh can be used outdoor. In fact, if you go to Ubiquiti's website, you can find U6 Pro listed under flagship section. Basically, it's treated as a regular indoor access point, but U6-Mesh is listed under outdoor. And from the description, you can see what's the main usage. Just due to its cute form factor, many people may choose to deploy it indoor on their desk. One thing I don't quite understand is why Ubiquiti even put the mesh in the naming. We will discuss that in details, but in my opinion, the better name for this access point should have been U6 Flex. This is the network topology for my home lab environment. I use a UDR to run the network controller. This PoE switch is a overkill for this particular U6-Mesh AP because to power this AP, you only need PoE switch. You don't even need PoE plus. And this access point only has a 1 gigabit port, so you don't need the 2.5 gigabit port for this particular switch. In this video, I'm going to use 6 physical machines to test the performance. So you can see in the middle, I have the PoE switch connected to the AP with another switch. And then this switch is connected with a Linux virtual machine using 10 gigabit connection. But the connection speed doesn't matter because, as I mentioned, this AP only supports 1 gigabit port. I'm going to use 3 Mac machines and 3 Windows PC machines. So as you can see, I marked the different radio bands which I'm going to use and their corresponding channel width which is supported by the particular machine. Because this AP only supports 2.4 gigahertz and 5 gigahertz, it doesn't support Wi-Fi 6E, which means 6 GHz. I'm going to test 2 radio bands. I will choose to test different channel width. For the same 5 GHz, I'm going to test both 80 MHz channel width and 160. And for 2.4 GHz, I'm going to use 20 megahertz and 40 megahertz. I won't talk about the details about the different channel widths for the corresponding radio bands. If you are interested, check my 2 separate videos in my channel. Basically, for this particular video, don't worry about different channel widths. The client machines, they should be able to connect to the access point without any problem. Before testing this access point as a wired AP, let's address the elephant in the room, the mesh wording in the model name. So in this current network topology, you can see I added another access point, U6 Enterprise. It is wired to this PoE switch. But for this U6 mesh, you can see there's a dash line here. The dash line means it's not wired, it's using mesh connection. Click this parent AP, if you will. We can find a mesh setting. Currently, it cannot be changed because it's already using the mesh function now. But by default, it's enabled. This is the parent AP, right? If we check the same thing for the child AP, which is U6-Mesh, you can find the same setting. So by default in UniFi network controller, the meshing setting is enabled by default. So that's why after I remove the Ethernet cable for this U6-Mesh, it's automatically switched to mesh connection and connected to the strongest signal AP, which is U6 Enterprise in my case. If you are interested in the connection speed, you can find the status under the U6 Mesh Overview tab. Scroll down. See, it says who's the mesh parent? It's U6 Enterprise. What's her signal? What's the transmitting and receiving speed? Don't think you will get this speed when you connect to this child AP, because there are a lot of factors, complexities when it comes to mesh, but at least you need to know for each hop, it will reduce at least 50% of the speed. So that's the theoretical maximum speed which you can get, which is 1 gigabit already. Let's test what's the speed we can get in this mesh situation. Keep in mind this is already the ideal situation because I put the parent AP and the child AP side by side. In real world, you won't have that situation at all. This is the diagram I'm going to use to test in this mesh connection situation. This is the U6 Enterprise. It's wired to this PoE switch, and for U6 mesh is powered by the PoE injector and connected using mesh connection. And I'm going to use just this Mac Mini to connect to the SSID, which is only broadcasted by this AP, not by U6 Enterprise, to make sure I'm testing the mesh connection speed. On this Linux, I'm going to run a iPerf3 server. Let's see what's the speed we can get. So on the screen, you see the Linux machine in the top right part of the screen, and in the middle right, this is the Mac Mini I'm going to use. On the Linux, let me run iPerf3 server, and on the Mac, I already made sure it's connected to this U6 mesh instead of the U6 Enterprise. And let me test the uploading speed with 10 parallel threads. Okay, see, this is the best speed that you can get. It's a little bit over 400 megabits. Maybe you are confused because in UniFi network controller, you already see the connection speed between the U6 mesh and the U6 Enterprise is about 2 gigabits, right? But why here we only achieve 400 megabits? Because of this additional hop, you are losing 50% of the speed already. And because here we are talking about Wi-Fi, you cannot simply treat the physical rate as your real-world TCP/IP connection speed. So basically, if you get half of the speed, you are already lucky. So that's why 2 gigabits times 50% times 50% again, you get about this speed. Okay, this makes sense. And this is what you can get in a mesh situation. In fact, I don't have to have this meshing scenario testing because in my opinion, this access point behaves in the same way as other UniFi access point. There's no any special meshing features. I don't know why Ubiquiti give it a name U6-Mesh. Any other U6 AP, they have the same meshing feature. Okay, now I wired the U6 mesh using Ethernet cable again. Now it has a 1 gigabit physical connection to the PoE switch. We are ready to test the speed in the non-meshed connection situation. So let me click on the U6 mesh. Let's check its wireless radio configuration. Go to setting. For 2.4 gigahertz radio, as you can see, I select the channel width 40 megahertz. And for 5G radio, I select 160 megahertz. Don't worry about, okay, what if your Wi-Fi client, they are old or for whatever reason they don't support the higher channel width. They will automatically use the lower channel width. U6-Mesh will support them without any problem. For example, this PC here, even though it does support Wi-Fi 6E, but it only comes with a special chip that only support 80 megahertz channel width. It doesn't support 160 megahertz. No problem. It can still connect. Another example is this very old Mac Mini. It only supports Wi-Fi 4, and for 2.4 gigahertz, it only support 20 megahertz channel width. No problem. It still can connect, even though in the AP side we set the channel width to 40 megahertz. I already remotely log on to the 6 computers. In the middle, 3 Mac machines. In the bottom, 3 PCs. In the upper right side, I have the Linux desktop. I show their respective connection speed. For example, these 2 computers, they are using 5G. For the middle 2, yes, 5G. Of course, they use different channel width, even though they are all 5G Hz radio band. And in the left part, these 2, they are both 2.4 gigahertz radio band, but they use different channel width. Okay, and for Linux, it's connected using Ethernet cable. It's the 10 gigabit connection. On the Linux virtual machine, I launched 6 separate terminal sessions. In each one, I run a dedicated iPerf3 server. They are listening to different ports so that I can use the same Linux to serve 6 parallel Wi-Fi clients for testing. And let's start with only one high-speed Wi-Fi client. This lower part Windows machine, it supports Wi-Fi 6E and it supports 160 megahertz channel width. Even though this AP doesn't support 6E, I still connect using the 160 megahertz channel width in 5 GHz radio band. This is the iPerf3 client I'm going to run. I have 10 parallel threads right forever and using this particular port. Okay, let me start it. Okay, so the speed is pretty good. It's close to 1 gigabits. This is acceptable. If you check the physical rate, let me show you in network controller. See, for this particular Windows machine, the physical rate is 2.4 gigahertz. So theoretically, I should get speed higher than 1 gigabit on the TCP IP side, right? But I only get 900 something. Why? Because this AP only has a 1 gigabit Ethernet port. So there's no way it can exceed the hard limit. And we can even try it from, let's say, this Mac machine. Let me connect to the 1.4 gigahertz radio band, right? It shouldn't have any radio interference with the existing 5G connection, so it should purely add on to the total throughput, right? So let me run the command. Similar command, but this time against different port. Okay, the speed here is miserable. It's lower than 50 megabit from server side. Let me show you the total throughput. Okay, from this graph, you can see the total receiving speed from the server perspective is close to 1 gigabit, which is the hard limit. So no matter how many new loads you add to the access point, it won't increase the total throughput from the Ethernet part anymore. Okay, that makes sense. Now from all other client machines, I already connect them to the AP and I'm ready to run the dedicated iPerf3 client commands already. But let's check their connection status in UniFi network controller first. You can find all the 6 Wi-Fi clients here. We already checked this particular Windows machine. For the other one, it's 1.2 gigabps for the Windows 10, 144 for the M1 Mac Mini, 1.2 gigabps. For the M2 is 2.4 and Mac Mini Intel is 144 megabps. Of course, they have different physical rate due to their different hardwares and due to their different distances with the AP, right? But let's see if we run all of them together, what's the overall throughput? Let me kick off those iPerf3 commands. Okay, they are all up and running. You can see from the server side, the overall throughput is not increased. Instead, it's even decreased because now the access point is busy reacting to 6 very demanding Wi-Fi clients, and it reduced its total throughput. Another important reason is I'm using 6 Wi-Fi clients. Some of them are using the same frequency, busily connecting to the same AP. There are a lot of radio interferences, so that also caused the throughput decrease. But basically, I just want to show you in this extremely busy scenario how the access point will react. Nothing surprising. The last thing I want to mention in this video is about its high temperature when it's busy. Due to its powerful abilities and extremely small form factor and its aluminum enclosure, it will become very hot. You won't be able to even hold it using your hand. And as you can see, the highest temperature I can measure is 144 Fahrenheit already. You may want to consider the temperature situation. Okay, to summarize what I think about this access point, I like its small form factor, features, and flexibilities, but I don't like its 1 gigabit RJ45 port. I don't like its high working temperature. Okay, thanks for watching.